Hello everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 5, Upthrust in Fluids, Archimedes Principle and Floatation. We will be discussing the topic relative density and the measurement of relative density using Archimedes Principle. Also, we will be solving questions from exercise 5B. Are you ready for the session? Let's begin. To understand relative density, first we need to understand what is density. So here, this experiment we have done in the previous session. Okay, I have explained this experiment. You are taking a tumbler of water and into it an iron nail and a cork is kept. What happens? You will be able to see that the iron nail will sink whereas the cork will float. Okay. Here, let's say that the mass of the iron nail and mass of the cork are the same. But still, even though they are of equal mass, you are able to see that one is sinking and the other is floating. Okay, there is the action of upthrust or the action of buoyancy here. Okay, now take this. You have a solid, you have a liquid, you have a gas. Here in a solid, you can see all the particles are very closely packed. One particle is touching the other particle. Very small amount of empty space is there inside a solid. But when it comes to the case of a liquid, in liquid you can see there are more empty spaces compared to the case of a solid. Okay, so here in the case of liquids, the particles are more closer than that in the case of gas, but they are at distance compared to the particles in a solid. What about gas? In the case of gas, the particles are very loosely packed. They are at a great distances. You can see the distance. So we say that, okay, here density, that is this is more denser. Denser means in the same space, you have taken the same space, the number of particles occupying that space is greater in case of solids, lesser than that in the case of liquids, and very less in the case of gas. So depending in the same space, the number of particles occupied is higher. Okay, which means we say that the density is higher in this case. Okay, when you take two objects, one object is sinking and the other is floating, which means when you compare, okay, the density of this object, that is nail, density of iron nail is greater than density of water. Because of this reason, the iron nail will sink. Okay. Now, why does the cork float? The density of cork is less than the density of water. Okay. So, we represent density with Greek letter rho. Okay. So, this is density. Now, consider that you are taking different objects. Let's say you have wood, iron, zinc, water, mercury and glycerin. Okay, we are taking equal volumes of these different substances. Okay, using a physical balance, we are measuring, we are finding its mass. We will be able to see that among this iron is having a mass that is greater than that of wood. Okay, so different substances, even the volume is same, their mass is different. Now, when you take a piece of lead and some cotton, let's say we are taking equal mass of lead and cotton. Okay, so when you find the volume, you will be able to see that the volume of the lead is small compared to the volume of cotton. So, why is it happening? In case of lead, the particles are more closely packed comparing to the cotton. Okay, so we have understood if you are taking equal volumes of different substances, the mass may be different. If you are taking equal mass of different substances, the volume may be different. So, density is something that depends upon mass and volume. Here we have said solid is having greater density. Solid is denser compared to liquid and gas. Iron is denser compared to the cork. Okay, so how do we say this? This density is something that is depending upon the mass and volume. When mass increases, there is a change in density. When volume increases, there is a change in density. Okay, now we can say that Density of a substance is its mass per unit volume. So density of a substance we can determine, that is equal to mass of the substance divided by volume of the substance. If you know the mass of the substance, you have measured the mass of the substance and its volume. If measured, we can find what the density of the substance is. So understood? This is about density. Now what is the unit of density? We have density is equal to mass by volume, or rho is equal to m by v, where m is the mass and v is the volume. This density, it is a scalar quantity. What are scalar quantities? A quantity which has only magnitude, there is no direction, is called a scalar quantity. So density is a scalar quantity. We know mass is also a scalar quantity. So rho is equal to m by v. Okay, what is the unit? So here we are going to get a derived unit. We have discussed about the fundamental units and derived units in the first chapter. So for density, we are going to derive an unit from the unit of mass and unit of volume. So what is the unit of mass? Unit of mass, SI unit of mass. First we will find the SI unit. Okay. SI unit of mass is kilogram. So unit of density is equal to kilogram per. What is the SI unit of volume? Volume, SI unit also we have derived, that is meter cube. Okay. Meter cube. So kilogram per meter cube is the unit of density. Unit of density is kilogram per meter cube. So this is the SI unit. Now what about the CGS unit? In a CGS unit, the length should be in centimeters, mass should be in grams and time should be in seconds. Okay. So here we need the mass in grams. Therefore, gram per length in centimeter, which means volume will be centimeter cube. Gram per centimeter cube is the unit of density in the CGS system. Now we are going to find the relationship between the unit of density in the SI system and the unit of density in the CGS system. So what is 1 kilogram per meter cube? Okay, we know that 1 kilogram is equal to 1000 grams. Okay, what about 1 meter? 1 meter is 100 centimeter. If 1 meter is 100 centimeter, then 1 meter cube will be equal to 100 centimeter into 100 centimeter into 100 centimeter, which is equal to 10 raised to 1, 2, 3, 4, 5, 6, 6 0. So 10 raised to 6 centimeter cube. Okay, so 1 meter cube is 10 raised to 6 centimeter cube. 1 kilogram is 10 raised to 3 grams. So this becomes equal to 10 raised to 3 grams divided by 10 raised to 6 centimeter cube, which is equal to 10 raised to 3. When this 10 raised to 6 goes to the numerator, it becomes 10 raised to minus 6. So 10 raised to 3 minus 6 gram per centimeter cube, or 10 raised to minus 3 gram per centimeter cube. Okay, so 1 kilogram per meter cube is equal to 10 raised to minus 3 gram per centimeter cube. Okay. Now what is 1 gram per centimeter cube in kilogram per meter cube? If 1 kilogram per meter cube is equal to 10 raised to minus 3 gram per centimeter cube, then 1 gram per centimeter cube will be equal to 1 kilogram per meter cube divided by 10 raised to minus 3. So this 10 raised to minus 3 goes to the denominator. Now when this is taken to the numerator, 10 raised to minus 3 becomes 10 raised to 3, which is equal to 10 cube kilogram per meter cube. Okay, therefore 1 gram per centimeter cube is equal to 10 raised to 3 kilogram per meter cube. Okay, so this is a conversion of the units of density in the SI system and in the CGS system. Let us take an example. Find the density of iron if the mass of 1 centimeter cube of iron is 7.8 grams. So here mass of iron is given. Mass of iron is equal to 7.8 grams. What else is given? Volume is given. Volume of iron is equal to 1 centimeter cube. Okay, now we can find density. Density is equal to mass by volume. That is 7.8 grams divided by 1 centimeter cube, which is equal to 7.8 gram per centimeter cube. Okay, if we need it in the SI unit, okay, if you have to convert it in the SI unit, what should be done? 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. So, 7.8 gram per centimeter cube is equal to 7.8 into 1000 kilogram per meter cube, which is equal to 7800 kilogram per meter cube. So, this we have directly converted the CGS unit into SI unit. Now, let's check this. Mass of iron is 7.8 grams, which will be equal to, in kilograms, how much is it? 7.8 into 10 raised to minus 3 kilograms. Okay. Now, 1 centimeter cube will be equal to 10 raised to minus 6 meter cube. Okay. Then what is the density on dividing? What do we get? 7.8 into 10 raised to minus 3 kilogram divided by 10 raised to minus 6 meter cube. That is 7.8 into 10 raised to minus 3 into 10 raised to 6 kilogram per meter cube, which is equal to 7.8 into 10 raised to 3 kilogram per meter cube. The same answer we are getting. This is 7800 kilogram per meter cube. 7800 kilogram per meter cube. Effect of temperature on density. So, we have said that solid is denser compared to liquid and gas. Density of solids is greater than, if you are taking in the same space, when you compare, the number of particles in a solid is greater than the number of particles occupied in a liquid is greater than the number of particles occupied in a gas. So, we have understood the density is greater in the case of solid. Now, if you are taking this, okay, that is, first you are taking a substance and you are heating it, okay. So, this is a cold, this is hot. What happens when you are heating? It starts expanding, okay. So, on heating a cold object, it starts expanding. So, with increasing temperature, what is happening? When temperature increases, there is expansion. Expansion means density is decreasing. Density decreases. So, when you take solid and gas, in gaseous state, the density is minimum. There the particles are loosely packed. Okay. Now, when you take a hot object and you are cooling it. Okay. So, this is a cold object. You are cooling. What happens? You are decreasing the temperature. Temperature is decreasing. When temperature decreases, what happens? The particles comes closer. Okay. Particles starts coming closer. That is, there is contraction. Okay, because of this, what happens to density? Density increases. So, normally with increase in temperature, there is decrease in density, and with decrease in temperature, there is increase in density. Now, this is not the case with water. So, anomalous expansion of water. Okay, so we will discuss about the anomalous expansion of water. So, when you take water, okay, we are taking water which is at a high temperature and you are cooling it. You are cooling means you are decreasing temperature. When temperature decreases, what happens normally? Okay, up to 4 degrees Celsius on decreasing temperature, that is, it starts contracting. Okay, contracts up to 4 degrees Celsius. So, once it reaches 4 degrees Celsius, what happens is on further decreasing temperature. So, you are decreasing the temperature further. Okay, on further decrease in temperature, what happens is from 4 degrees Celsius to 0 degrees Celsius, here it is not contraction. Further contraction won't happen. There is expansion. Okay, there is expansion. Here it starts expanding. So, this is the only case with water. This is an exceptional case. Normally on decreasing temperature, what happens? There is, when temperature decreases, what happens? There is contraction. But here on further increasing temperature from 4 degrees Celsius, there is expansion happening. This is the only case with water. So, the density of water is maximum. So maximum density will be at 4 degrees Celsius equal to 1 gram per centimeter cube or 1000 kilogram per meter cube. This is the density of water. So density of water is when the water is at 4 degrees Celsius. This is a maximum value. Okay. Now what is relative density? Let us discuss what is relative density. So relative density is when the density of a substance is compared to the density of another substance. So here standard we have the density of water. What is the density of water? Density of water at 4 degrees Celsius is taken as some standard is equal to 1000 kilogram per meter cube or 1 gram per centimeter cube. Okay, so relative density is nothing but the density of a substance relative to the density of water or density of a substance with respect to the density of water. So, the ratio of density of a substance to the density of water at 4 degrees Celsius is called the relative density. So, relative density represented as RD of a substance is the ratio of the density of that substance to the density of water. Remember, it is happening at 4 degrees Celsius. Okay. So, relative density is equal to density of substance divided by density of water at 4 degrees Celsius. This is one way in which we can define relative density. Okay. Now, when you took the first case, that is iron nail and cork which are put into water, you have seen that the density of iron nail is greater than the density of water. Okay. Then also we have found the density of cork is less than the density of water. Okay, which means you will understand the relative density of the iron nail is, that is relative density of iron nail is greater than the relative density of cork. Okay, so this is one way you can define. If the density, if you are taking unit volume, okay, unit volume of substance, then you can say that the relative density is equal to mass of unit volume of substance divided by mass of unit volume of water at, when you include water, it should be at 4 degrees Celsius. So, this is the second way in which you can define. Now, the third way in which you can define is, so here we have taken unit volume. Now, consider you are taking some certain value, okay, some fixed value. So, mass of that fixed volume or a certain volume of substance and that much volume of water should be taken which is at 4 degrees Celsius. Okay, this is also relative density. So, relative density of a substance is also defined as the ratio of the mass of a certain volume of a substance to the mass of an equal volume of water at 4 degrees Celsius. Okay, at 4 degrees Celsius. Clear? So, when you take water in a tumbler and you put different objects, okay, you will be able to see that when you compare the relative densities, the relative density of A, which is at the bottom, will be the highest and B, which is at the top, will be the lowest. Okay, so any objects that are in between will be having relative density between that of A, that is less than that of A and greater than that of B. Okay, so understood what is relative density? Now, what is the relationship between relative density and density? So, if density is given, you will be able to find what the relative density of the substance is. If relative density is given, you will be able to find what the density is. So, we have the relation, okay. So, relative density is equal to density of substance divided by density of water at 4 degrees Celsius. Now, what is the density of water at 4 degrees Celsius? Density of water is equal to 1 gram per centimeter cube or 1000 kilogram per meter cube. Okay. Now, if you know the density of the substance, okay, we can find the relative density. So, relative density of the substance will be equal to density of substance if taken in gram per centimeter cube divided by divided by density of water in gram per centimeter cube. What is it? It is equal to 1. So, 1 gram per centimeter cube. Okay. So, you will be getting relative density is equal to density of the substance when the unit is gram per centimeter cube. So from this you will understand that the relative density is a ratio. Okay. Since it is a ratio, there is no unit. You have seen that here I have cancelled gram per centimeter cube and gram per centimeter cube. So relative density is a quantity which has no unit. Okay. Now if you are taking the densities in kilogram per meter cube, then let us see relative density will be equal to density of the substance in kilogram per meter cube divided by density of water in kilogram per meter cube, which is 1000 kilogram per meter cube. Okay, that is 1000 kilogram per meter cube. Units can be cancelled. Then you will be having density of substance divided by 10 raised to 3, which is equal to density of substance into 10 raised to minus 3. There is no unit. So if the density of substance is in kilogram per meter cube, put the value and put into 10 raised to minus 3. Then you will be getting the relative density. Okay. So relative density, when you take, it will be a fixed value for a substance. Okay. When it is with relative to water. Clear? Now let us find relative densities of some substances. Okay. For copper, the density is given to be equal to 8.9. So we have said that. Okay. Here the density is given in gram per centimeter cube. So what is the relationship between relative density and density? Here relative density will be equal to density. Since this is 8.9 gram per centimeter cube divided by density of water at 4 degrees Celsius. 1 gram per centimeter cube, which is equal to 8.9. Okay, that is density and relative density are equal when the unit of density is in gram per centimeter cube. Now the second one for mercury. For mercury, the density in gram per centimeter cube is 13.6. What is the relative density then? 13.6 divided by 1, which is equal to 13.6. For silver, 10.8 is the density. Relative density is 10.8. Okay. Next for gold, the density is 19.3. Relative density will also be 19.3. For platinum, 21.5. 21.5 is the relative density. Aluminium, 2.7. Relative density is also 2.7. Next, iron, 7.86. Relative density is also 7.86. Okay. So we know the relation between gram per centimeter cube and kilogram per meter cube. What is the relation? Gram per centimeter cube will be equal to 10 raised to 3 kilogram per meter cube. Okay. So if it is 8.9 gram per centimeter cube, it will be equal to 8.9 into 10 raised to 3 kilogram per meter cube, which is 8900 kilogram per meter cube. Okay, if we are taking in kilogram per meter cube, then the density of water should also be in kilogram per meter cube, which is 1000 kilogram per meter cube. So if you take 8900 is the density of the substance. So here the density of copper in kilogram per meter cube and density of water in kilogram per meter cube is 1000. Okay, so on cancelling zeros, you will be again getting 8.9. Relative density, the same value you are getting even though densities are taken. First case we are taking in gram per centimeter cube. Second case if we are taking in kilogram per meter cube. You will get the same values, only that it gets cancelled there. Clear? Now here we have some substance whose density is given in kilogram per meter cube. We have to find the relative density. So what is the relation here? Relative density will be equal to density into 10 raised to minus 3. Okay, density, what value you get into 10 raised to minus 3. Now, here we have for core, the density is 240 kilogram per meter cube. Okay, so 240 divided by, relative density will be equal to 240 divided by density of water 1000. Okay, so you will be getting 0.24. 0.24 is the value. That is 240, the given value, into 10 raised to minus 3. Just you have to do this. Okay, the density value into 10 raised to minus 3, which will be equal to 0.24. Okay, next, in the case of wood or pine, the density is 500 kilogram per meter cube. Okay, which means relative density will be equal to 500 divided by 1000, which is equal to 0.5. That is 500 into 10 raised to minus 3. For petrol, 800. 800 into 10 raised to minus 3, which is 0.8. Turpentine, 870. 870 into 10 raised to minus 3, 0.87. Next, ice, 920. 920 into 10 raised to minus 3, 0.92. Next is olive oil, 920, same value. That is, we have the density of olive oil and density of ice the same, that is 920. 920 into 10 raised to minus 3, again 0.92. Pure water, 1000. 1000 by 1000 is 1. Sea water, 1025, therefore 1.025. Glycerin, 1260. 1260 divided by 1000, 1.26. Okay, so these are the relative densities when density is given in kilogram per meter cube. Now, what is the difference between density and relative density? So, let's compare. So, first density, define first. When you have to differentiate between two things, you will have to put the definition first. Definition of the first one, definition of the second one. This is the first point. Okay, so density of a substance is a mass per unit volume of that substance. Now, what about relative density? Relative density of a substance is the ratio of density of that substance to the density of water at 4 degrees Celsius. Density is equal to mass divided by volume. Relative density is equal to density of substance by density of water at 4 degrees Celsius. Now, the second point, it is expressed in two units of densities are gram per centimeter cube and kilogram per meter cube. What about the case of relative density? Relative density is the ratio of densities, therefore there is no unit. It has no unit. So, these are the two important differences between density and relative density. Determination of relative density of a solid by Archimedes principle. What is Archimedes principle? When object is fully or partially immersed in a liquid, it experiences an upthrust. So, when you drop an object inside a glass of water, what happens? You can see that the level of water is rising or water drops out. That is the amount of water. If you are filling the tumbler till the brim, you will be able to see that when you put an object inside, the object will occupy a space, therefore water will have to be thrown out of it. Okay, so the volume of water that is getting displaced will be equal to the volume of the object, which means the weight of water that is displaced will be equal to the weight of the object. So, here we have relative density. We have defined relative density is equal to mass of the body divided by mass of water at 4 degrees Celsius of volume equal to that of the body. So, we have relative density is equal to mass of body divided by mass of water displaced at 4 degrees Celsius. Okay, which means the weight of the body will be equal to weight of the body divided by weight of water displaced. Okay, now we have spoke about the actual weight, apparent weight and upthrust. What is the relation? We have apparent weight. Apparent weight is equal to actual weight minus upthrust. Okay, so we have discussed all the experiments, that is when you weigh an object in air and when you weigh an object in water, you will be able to see that there is a difference in weight. Yes, that is the weight of the object will be decreasing. Why? Because there is an upthrust. It experiences an upthrust. Okay, so here you are having, you can find the upthrust, that is upthrust will be equal to actual weight minus apparent weight, from which apparent weight will be equal to actual weight minus upthrust. Okay, so when you weigh an object in air, let's say the weight is W1, that is weight in air. W2 is the weight in water. Okay, now we know that upthrust is equal to the weight of the water that is displaced. Okay, we have discussed this. So, upthrust is equal to weight of water displaced. Weight of water displaced. Okay, so then here you will be getting upthrust. Okay, now what is upthrust? Upthrust is equal to actual weight. Here actual weight is a weight in air, which is W1 minus apparent weight, that is the weight in water, which is W2. When it is taken out of water, again the weight will become W1. So the upthrust is equal to W1 minus W2, and upthrust is the weight of water displaced. Okay, now weight of the body is anyways weight of the body in air, that is W1 divided by W1 minus W2. So this is how you can find relative density. Relative density is equal to W1 divided by W1 minus W2, where W1 is the weight of the body in air and W2 is the weight of the body in water. So what is the relation between weight and mass? We have, according to Newton's second law of motion, force is equal to mass into acceleration. Okay, now we know that weight is a force, force of gravity, that is with which, the force with which the earth pulls us is the weight. Weight is the force, will be equal to mass into, here the acceleration is because of the gravity. So this acceleration is acceleration due to gravity. Okay, so the relation between weight and mass is weight is equal to mass into acceleration due to gravity. So on weighing a body with a physical balance, so when you try to find the weight of a body using a physical balance, you will be getting mass in units of gram or kilogram. Okay, if you get in gram or kilogram, the weight will be in units kilogram force or gram force. Okay, so if you are having 2 kilogram is the mass. If mass is 2 kilogram, it means the weight will be equal to 2 kilogram force. If your mass is 5 kilogram, then the weight will be equal to 5 kilogram force. If your mass is 100 grams, then your weight will be equal to 100 gram force. Okay, so this is the relation between mass and weight. Procedures to determine the relative density. So first we will be discussing two cases. First case is when the solid is denser than water and insoluble in it. Okay, relative density of a solid denser than water and insoluble in it. This is the first case we are going to discuss. Okay, so first you take the solid whose relative density is to be determined. Then it is suspended on a piece of thread from the hook of the left pan of a physical balance. So using the physical balance, we are going to find the weight of the body. Okay, we'll determine the weight in air. So weight in air, let's say we got W1 gram force. Okay, W1 gram force. Now next what you have to do is, so relative density is with respect to water. Okay, so we need water here. So on the left pan, keep a wooden bridge. Okay, after keeping a wooden bridge, take a beaker which is 2/3 filled with water. So the beaker is kept. You have to remember one thing, that is neither the beaker nor the wooden bridge will touch the left pan, should not touch. Okay, so here this is how the setup is. Then try to suspend the solid inside the beaker. Okay, so it gets fully immersed in the water inside the beaker. Should remember one more thing, that is the solid does not touch the walls of the container, walls of the beaker or the bottom portion of the beaker. So once you suspend, you will be able to note the weight. Okay, so weight in water, weight of the body in water will be equal to W2 gram force. So what happens? You will know that there will be a decrease in weight. There is a loss of weight. Loss of weight in water will be equal to W1 minus W2. Then what is the relative density? Relative density will be equal to weight in air W1 divided by loss of weight in water, that is W1 minus W2 is equal to weight of body in air divided by loss of weight in water. So here we have taken a substance, that is the object that is taken, the solid that is taken is having a density greater than the density of water. Okay, 1 point. Second, it is insoluble in it. Okay, when you take salt, salt is soluble. Okay, salt is soluble. So here the solid that is taken is insoluble. In that case, you will be getting relative density is equal to weight of body in air divided by loss of weight in water. Okay, loss of weight. How to find loss of weight? Weight in air minus weight in water. Now, the second case is when the solid is denser than water and soluble in it. Relative density of a solid denser than water and soluble in it. Okay, so here again the same procedures are taken, but one thing is that you have seen here the substance is, the object or the solid is soluble in water. Okay, in that case you will have to take another liquid. Okay, another liquid of known relative density. You should know the value. You should know the relative density of that liquid. Such a liquid should be taken. Okay. Now again, the same procedure, that is take the object, suspend it, find its weight. You will get W1. Okay. Next, you have to suspend it inside the liquid which you have taken. Not the weight, that will be W2. Okay. There will be loss in weight, W1 minus W2. Okay. Now, to find the relative density, here the relative density of the solid will be equal to weight in air divided by loss of weight in liquid. So here we cannot take water because the substance is soluble in water. So instead of water, we are taking a liquid whose relative density is known. Okay. So here now you will have to multiply with this the relative density of the liquid which we have taken. Then we can find the relative density of the solid. Okay. So here relative density of solid. Normally relative density of the solid is equal to weight in air divided by loss of weight in water. Instead of water, if you are taking any other liquid of known relative density, then the relative density of the solid will be equal to weight in air divided by loss of weight in the liquid into the relative density of liquid. Okay. So this is how you will find when the solid is soluble in water. Determination of relative density of a liquid by Archimedes principle. By now we have discussed the procedures to determine the relative density of a solid by Archimedes principle, whether it is a soluble solid or an insoluble solid. We know the procedures. Now how to find the relative density of a substance, of a liquid, using Archimedes principle. So according to Archimedes principle, we know that when an object is immersed in a liquid, what happens? Equal volume of the liquid or water will get displaced. Okay, whether it is liquid, if it is in some other liquid other than water, when the object is immersed in it, what happens? A volume of liquid is displaced, that is equal to the volume of the substance. Yes, if it is water, then this much volume of water will be displaced, which is equal to the volume of the substance. Now we have relative density is equal to weight of a given volume of the liquid divided by weight of the same volume of water. Okay, this much volume of water will be displaced. Now, when you take a substance, that is when you take, to find the relative density, the procedure is you take some substance, you take some solid such that the density of the solid is greater than density of water and the density of liquid. Okay, it should be insoluble. These two things you have to note. The substance should be, the solid should be insoluble in water and in the liquid, and its density should be greater than the density of water and density of the liquid. So first we will be weighing the solid. Okay, you will find the weight of solid in air, that is W1. Next, you will immerse the solid in the liquid. Okay, in the liquid, you are going to immerse it in the liquid whose related density is to be determined. So, when you immerse it in the liquid, you will be able to note the weight. Let that weight be equal to W2. W2 is the weight in liquid. Next, what you have to do is you have to remove it from the liquid and then clean it and dry it. Okay, until you should remember there should be no liquid that is stick to the solid. Okay, it should be completely properly washed and dried. After that, dip it inside water and find the weight in water, which is W3. Okay, now we have relative density is equal to weight of a given volume of the liquid, which means it is equal to, relative density is equal to loss of weight in the liquid. Yes, this loss of weight in the liquid will be, that is the body's loss of weight in the liquid will be equal to the weight of a given volume of the liquid. Yes, divided by loss of weight in water. So, what is the loss of weight in liquid? It will be equal to weight in air W1 minus weight in liquid W2 divided by. What is the loss of weight in water? Weight in air W1 minus weight in water W3. So, this is how you can find the relative density. Relative density will be equal to weight in air minus weight in liquid divided by weight in air minus weight in the water. W1 minus W2 divided by W1 minus W3. So, this is how you can find the relative density of the liquid. It is not that you will just add the liquid into water and find the relative density. This is not possible. You need to have a solid. It is not necessary you know the relative density of solid. But one thing to remember is the density of the solid should be greater than the density of liquid and water taken, and also it should be insoluble in the liquid and water taken. Okay. We'll take another example. Relative density of silver is 10.5. What is the density of silver in SI unit? What assumption do you make in your calculation? So, here relative density of silver is given. Relative density of silver is equal to 10.5. We have to find the density of silver. Okay, how to find? We know relative density of silver will be equal to density of silver divided by density of water at 4 degrees Celsius. So, what is the density of silver? Which is, you have to determine the density of silver. Then you will be having density of silver equal to relative density of silver into density of water. So, here what is the relative density of silver? 10.5. Density of water. So, here it is given that you have to find the density of silver in SI unit. In SI units, what is the density of water? Density of water is equal to 1000 kilogram per meter cube. Okay. Now put, you will be getting 1000 kilogram per meter cube. This is equal to 10.5 into 1000, that is 10.5 into 10 raised to 3 kilogram per meter cube, or 10,500 kilogram per meter cube is the density of silver. Now, second part of the question, what assumption do you make in your calculation? So, here in this question it is not given that the density of water is 1000 kilogram per meter cube. We have taken the density of water to be equal to 1000 kilogram per meter cube. This is a known value. So, the assumption made is we are taking the density of water equal to 1000 kilogram per meter cube. Third example, a body A solid body weighs 2.1 Newton in air. Its relative density is 8.4. How much will the body weigh if placed first in water, then in a liquid of relative density 1.2? So what is the relative density? Relative density is equal to W1 divided by W1 minus W2. Okay, where W1 is the weight of the body in air. So here it is 2.1 Newton. W2 is its weight in water, which we have to find. Then what else relative density is given? To be equal to 8.4. So substituting 8.4 is equal to 2.1 divided by 2.1 minus W2. That is 8.4 into 2.1 minus W2 is equal to 2.1, or 2.1 minus W2 is equal to 2.1 divided by 8.4. Okay, so 2.1 minus W2 is equal to 2.1 divided by 8.4. 2.1 into 4 is 8.4. So you will be getting 1 by 4. 1 by 4 is 0.25. 0.25. Now we can find W2. W2 will be equal to 2.1 minus 0.25, which is equal to 1.85 Newton. So weight in water. Weight in water is equal to 1.85 Newtons. Now the second part of the question we have to find in a liquid of relative density 1.2. Okay, in that case the relative density of the body will be equal to weight in air W1 divided by loss of weight in liquid W1 minus W2 into relative density of the liquid. Okay, so here W1 is weight in air and W2 is weight in the liquid. So relative density of body we know, which is equal to 8.4. That is weight in air 2.1 divided by 2.1 minus W2 into relative density of the liquid is 1.2. Okay, so this is 8.4 into 2.1 minus W2 is equal to 2.1 into 1.2, or 2.1 minus W2 is equal to 2.1 into 1.2 divided by 8.4. So when cancelled you will be getting 4 over here, and this becomes 2.1 minus W2 is equal to 1.2 divided by 4 is 0.3. Then what is W2? W2 is equal to 2.1 minus 0.3, which is equal to, when you subtract you will be getting 1.8 Newton. So weight in liquid is equal to 1.8 Newton. 1.8 Newton. Okay. Now let us solve problems from exercise 5B. Question 1 of exercise 5B. The density of copper is 8.33 gram per centimeter cube. Express it in kilogram per meter cube. So we know 1 gram per centimeter cube is equal to 10 raised to 3 kilogram per meter cube. How we are getting this? We know 1 kilogram per meter cube is equal to 1000 gram divided by 10 raised to 6 centimeter cube. This is equal to 10 raised to minus 3 gram per centimeter cube. So 1 kilogram per meter cube is equal to 10 raised to minus 3 gram per centimeter cube, or 1 gram per centimeter cube is equal to 10 raised to 3 kilogram per meter cube. So this is how you obtain this relation. Now here we have 8.33 gram per centimeter cube. Then it will be equal to 8330 kilogram per meter cube. So this is the density of copper in the SI unit kilogram per meter cube. 8330 kilogram per meter cube. Question number 3 of exercise 5B. The density of iron is 7.8 into 10 raised to 3 kilogram per meter cube. What is its relative density? How to find the relative density? We have the density of iron is equal to 7.8 into 10 raised to 3 kilogram per meter cube. We know density of water is equal to 1000 kilogram per meter cube. So here the unit is kilogram per meter cube. Therefore 1000 kilogram per meter cube. Then the relative density will be equal to density of iron divided by density of water, that is 7.8 into 10 raised to 3 divided by 1000. Okay, the unit is kilogram per meter cube. Here again kilogram per meter cube. Units gets cancelled. 10 raised to 3 and 1000 are the same. So you will be getting relative density 7.8. There is no unit. So relative density of iron is equal to 7.8. 7.8 is the relative density of iron. Question number 8 of exercise 5B. A body of volume 100 centimeter cube weighs 1 kilogram force in air. Find its weight in water, its relative density. So to find weight in water, here we are given volume is equal to 100 centimeter cube, which is equal to, we have 1 meter equal to 100 centimeter. Then 1 meter cube will be equal to 10 raised to 6 centimeter cube. 1 centimeter cube will be equal to 1 by 10 raised to 6 meter cube, which is equal to 10 raised to minus 6 meter cube. Okay, so here we have 100 centimeter cube. So 100 centimeter cube will be 100 into 10 raised to minus 6 meter cube, that is 10 raised to minus 4 meter cubes. Okay. So this is 10 raised to minus 4 meter cube. This is a volume. Now we need mass. How to find mass? Here it is given that the weight is 1 kilogram force, which means mass will be equal to 1 kilogram. Then we can find the density. The density of body is equal to mass by volume. Okay, so rho is equal to m by v, which is equal to 1 divided by 10 raised to minus 4, which is 10 raised to 4 kilogram per meter cube. So we got the density of the body. Okay, first we have to find its weight in water. Okay, now what is the relative density? Relative density of the body will be equal to density of the body divided by density of water, that is 10 raised to 4 divided by 10 raised to 3. 10 raised to 3 kilogram per meter cube is the density of water. So you will be getting relative density 10. So we have first determined the relative density. So second answer we got, that is 10. Now using relative density, we can find the value of the weight in water can be determined. So how to find the weight in water? We have relative density of a body is equal to weight in air divided by weight in air minus weight in water. So W1 is the weight in air and W2 is the weight in water. So relative density value we have, that is 10, equal to weight in air 1 kilogram force. Okay, so 1 divided by 1 minus W2. So 10 into 1 minus W2 is equal to 1, or 1 minus W2 is 1 by 10. Okay, and then W2 will be equal to 1 minus 1 by 10 equal to 10 minus 1 by 10, that is 9 by 10. Okay, so W2 is equal to 9 by 10 or 0.9 kilogram force. So when you convert it into gram force, this will be equal to 900 gram force. 900 gram force. That's all for today. In today's class, we have discussed about relative density. What are the differences between density and relative density? How to measure relative density using Archimedes principle in the case of solids and in the case of liquids. Also, we have solved questions from exercise 5B. There are other questions which you can solve on your own. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.